Okay, we're live. Okay, so let's just talk about, first of all the mathematical symbols that we'll be seeing when we're doing trig and when we're doing this stuff. And the first one is this guy right here, okay? What is that guy? Anyone ever seen him before in your travels? Nobody? Yes? No, that's a good guess. Anyone? No? Really? Okay, this is what we call theta, and it means unknown angle. That is the Greek symbol that is always used when we talk about, so you know how you'll see sine theta? Okay, that's sine, what angle? Or they may have a triangle drawn and they may ask you for theta. So it's like a circle with a line drawn through it. So if you see that, they want me to find that angle. Okay? This sign right here. Okay? This means similar. Now, in mathematics, similar means something quite specific. In the in English language, similar means they're alike, but similar means same shape. So it doesn't mean they're the same size. So these two here are similar. It's like the one triangle is just a blow up of the other. All the angles will be the same, but the size isn't. Okay? That's where we get to this one. This one means congruent. Congruent means same shape and size. So these two would be congruent. They are the same identical shapes. Okay? This one here means not equal to. Okay, so 5 is not equal to 2. Right? Simple statement. Okay? This here means angle. So you may see angle ABC. Okay? This means triangle. And in science, it also means change in. So you may see delta T. Delta T, that's what that means, delta. Delta T means change in time. Okay? Delta M would be the change in mass. Okay? But for us, we'll like triangle ABC, we would just, instead of writing triangle, just draw a little triangle, right? And this means approximately equal to. And it could also be like that, right? Remember how it's on our formula sheet? It's pretty close. It's approximately. It's not exact. Like we could say pi is approximately 3.14. But it's not really 3.14. It's 3.141592. Blah, 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 blah. It goes on forever, right? Okay. Angle properties. When you have opposite angles, so we're on the next page, right? No? Oh, same page for you guys, yeah. Yeah. So you want to draw two lines like that. Okay, so I'm just going to Where's my delete button? I'll just get rid of these because it confuses students when notes are already there, right? Okay, so when you have two lines that intersect, something always occurs. This angle here will always be the same as this angle here. So opposite angles are always equal. Okay, so if this would be angle Y here, this would be angle Y there, because they're opposite each other. And you'll also learn that X and Y together would always equal 180 degrees, because it's those two angles add up to the line. Okay, now parallel lines. If you had two lines that were parallel, it means they're running beside each other like railroad tracks, totally at the same level. And with parallel lines, we're going to learn a lot of things, but if you take a parallel line and you cut it with a, we call a transversal, so if you cut it with a line, there's a lot of things that occur. Like this angle here would be equal to this angle here. And what do we know about this angle here and this angle here? They're opposite, aren't they? So if they're opposite, this angle would also equal this angle. And this angle is opposite this, so it would also equal this angle. Okay, so when you have two parallel lines, those four angles would equal each other. And this angle, since they're opposite, would equal that angle. And then when we learn with corresponding, these two would be equal. See how these two x's are equal, these two y's are equal, and then these two are opposite, so they would be equal. And then again showing that these two are equal. Okay, those are all called corresponding angles. This one corresponds to this. This one corresponds to this. And these are called opposite angles, just like we learned up here. That opposite angles, if they're opposite each other, they are the same. Okay, what's a parallelogram? Anyone remember? Two sets of parallel lines opposite each other. So these two and say these two. And the parallel lines is done by this. It's like a little arrow. And so those two would be parallel each other. And these two, you might put two of them on there saying those two are parallel. Okay? And one other thing I want to talk about is just how we name triangles. Now, if you were to draw a triangle, does anyone know what it's called where two lines meet? Right here. Good. It's a vertice. So vertices okay, two lines meeting are always labeled with capital letters. We can also call that uppercase. Right? Vertices, two lines meeting, and they are always labeled with capital uppercase letters. So I would label this A, B, C, or X, Y, Z, or Q, R, S. Doesn't matter. But just make sure they're capital letters. Now, the sides are labeled with lowercase letters. So, but you just can't go, like I've got triangle ABC, you just can't put, I don't know, put like XYZ on there. there's a specific way that we have to label these sides. Now, do you see where A is? There's a side that is opposite it. See that side? If you were standing there with a bow and arrow, that's the only side you could hit. The side opposite will get the lowercase. So that's called side A. Sides are labeled with lowercase letters. Okay? Therefore, what will we call this side right here? C, little c. And therefore, this would be B. Okay, and one more small little piece of review. Angles of a triangle all equal or add up to what? 180 degrees. Okay, so hopefully that's review, but it's summers are long. We forget a lot of stuff. And math is a language, right? And if you don't use it for a while, you forget it. And it doesn't take long. I lived in another country that didn't speak English for like 6 months. And I could speak it. Not well, but I could speak it when I left. And probably 6 months after that, I forgot pretty well all of it, right? Because I wasn't using it anymore. I was back in an English country talking English the whole time. So, you know, it's funny how good you can be with it. And then bang, you know, and math is very much that way. Okay, you might have heard of the Pythagorean Theorem by Pythagoras. And he says if there's a right angle triangle, right, this is our right angle right here. There's our right angle. So if two sides meet at 90 degrees, those two sides are always going to be labeled A and B. Now, some people like to call A the height, but in a triangle, it's given its own name, and that is the altitude. So the altitude is what students usually think of the height. And the base, that students know that is the base, right? That's all that's ever been called. But you can mix up A and B. It's not going to hurt you, okay? The thing is, you must always have C as the hypotenuse. And the hypotenuse, it does not touch the right angle, so it never shares the right angle, and it's always the longest side of the triangle. Okay, so what we're going to do is we're just going to work with a few of these. Oh, I got a treat for you. I thought maybe you might want Darth Vader to teach you this instead of me, so here you go. Okay, I just have to get rid of that.
Good morning, class. Today I will be teaching you the Pythagorean Theorem. It is your destiny. We begin with a circular line triangle. If we know the lengths of sides A and B, we can calculate the length of side C, the hypotenuse. The hypotenuse is the long side of the triangle. I prefer to think of it as the dark side. Note on the left, the dark side of the triangle. To find side C, you are free to use any methods necessary, like no disintegrations. The Pythagorean theorem states that the sum of the squares of the two short sides equals the square of the hypotenuse. A squared plus B squared equals C squared. All too easy. Let's look at an example. The side A is 5 centimeters long, and side B is 12 centimeters long. A squared plus B squared equals C squared, according to Pythagorean theorem.
You should be using lowercase letters, though.
Both sides to isolate C. So the square root of 5 squared plus 12 squared equals C. The hypotenuse. 5 squared is 25. 12 squared is 144. The side is long, isn't it? Square root of 169 equals C. I have you now. 13 equals C. The circuit is now complete. The hypotenuse of this triangle is 13 centimeters long. Impressive. Most impressive. Just remember, kids, don't be too proud of this geometrical terror you create. Only to calculate the length of the hypotenuse, insignificant an hour of the first. There you go.
Oh, probably. Someone spent some good time on that one. Okay. Oops. Okay, so let's go through and do some of these, and then you'll have lots of time to work in class and get your homework done in class. So you don't have homework, which is always the best. Okay, so we have 12, 7, and then our x. Now, we would call this A, B, and C. And you see in the video, he labeled his with uppercase A, B, C, but that would be incorrect. Maybe that's American. I don't know. Now, the formula that I always write down, first of all, is the one that I know. A squared plus B squared equals C squared. Okay? That's a nice, easy one to remember. It's the first 3 letters of the alphabet, and you square it. Now, our unknown is C. But I have this formula, and it says equals C squared. I need this to equal C. What do you do to C squared to make it C? Square root it. And you know in algebra, what you do to one side, you do the other, right? You've heard that enough times. So you do that to both sides. So the formula is A squared plus B squared. And I'm actually going to try to encourage you guys to be doing this in one step in your calculators. Okay? So first of all, let's substitute. A, see my A? 12 squared plus B 7 squared equals C. So the way that we do this in our calculator, okay, just got to get out of here. So you take your square root sign, and it will open with a bracket. And then you just go 12 squared plus 7 squared. So you're doing it all in one step. You're not going to square 12, write it down. Square 7, write it down. Add the two together. Then take the square root. It's not only longer, but every time you do an extra step, it increases your chance to make a mistake. So I look at it, looks good, and then, okay. And this one didn't ask us where to round, but let's round to the nearest 10th. Okay, so the nearest 10th would be 13.9 centimeters equals C. Now, I hate memorizing a lot, right? But so I try to memorize as little as possible. So whenever I do a question, I know this one, A squared plus B squared equals C squared. So I write that down. Now there's 2 other formulas you need to know, the one to solve for A and the one to solve for B. But instead of memorizing those ones, I know this one, and I just do a little algebra. I want to get A squared by itself, right? Because look, I'm looking for A. That's B and that's C. In this case, I'm looking for A. How do I get B squared out of there? Yes. Add the opposite or subtract, right? So if I minus B squared to both sides, I would get that. Okay? Now, same thing. It says A squared equals. So I'm going to do the square root of both sides. So A equals the square root of C squared minus B squared. Now, I know what some of you are thinking. That's easy to remember. I'll just remember always C squared minus B squared, square root, right? I got it. But I did want to show you how that came to be. I just didn't want to write it down and say, that's the formula. And someone goes, well, how'd you get that? Doesn't matter. Memorize it. That's all you need to do, right? That's what makes math really crappy when people don't even help you understand it. It's like, it's magic. Don't worry about it. Just write it down, right? And you're like, but I don't know how it works, right? So that's exactly what we did. We did algebra on it. We subtracted the b squared out on both sides, and then I took the square root of it. And then A equals, and I'm going to put in my stuff. I got my C, which is 12 squared, minus B is 10 squared. And if you did it wrong and you put 10 squared minus 12 squared, you get a negative number. If you take the square root of a negative number, you get an error because you can't take the square root of a negative number. So you really can't mess it up. You'll either get an answer or you'll get no answer. But I guess one thing you could do is you could add it here. I guess that would be bad, right? There's no addition sign there. And when you put that one in, you'll get A to equal 6.6 centimeters. Okay. Oops. Okay, so everybody's favorite word problems, right? Why do they call them problems? Problems are never good. So they're like word challenges. Yeah? Just a sec. Yeah, your calculator might be different than the rest. You probably have to put your number in and then hit square. Okay, so you want to try and get the TI 83 plus or the TI 84. And that's something you'll be able to use for all 3 years. Take it to your diploma and you'll rock the diploma because you know that calculator so well, where yours won't be able to graph. I'm going to teach you some really neat tricks on those calculators that you're going to be like, really? It does this? Right? Stuff that you've maybe been challenged before, and you'll see how your calculator does it. And it's not like I'm trying to take away, no, you still need to learn it, but it's a nice tool to check. And since you get to bring it in your diploma, it's nice to have that thing to check with, right? Now, here we have a guy wire is attached to the top of a 10-meter pole and is anchored 2 meters from the base of the pole. Find the length of the wire. Okay, so first of all, let's just draw a pole. Okay, you know those like electrical poles, right? They have like, you know, this thing here, and then I want to make it look like a cross. And the wires. Again, don't be intimidated by my drawings. I'm a trained professional. So obviously they're going to be pretty high caliber, right? But you just do your best. That's all you have to do, okay? Thank you. Now, that pole is 10 meters tall. And it says there's a wire attached to the top of the pole, and it goes down to the ground, and it says that it is 2 meters from the base of the pole. You can see why this would be a Pythagoras question because it's a right angle triangle. Okay, which letter are we looking for? C. Okay, 10 would be what? A. And that would be B. Okay? Yes. Yes. Yeah, it would have to be that assumption, or else we'd have to do oblique triangles, which you'll learn later. Okay? Because that's a different question. A pole has blown over. It's got a 5-degree angle. What would be and the wire stretched? What would be the length of the wire? So that's where that actually, they take these questions and do that. Make sure you're copying it down, everybody, right? Okay, so remember, a squared plus b squared equals c squared. I'm looking for c, so that's a squared plus b squared equals c. So it's important. I want you to always be writing down the formula. You'll find this when you take science, but when I would mark a science question, it would be worth 3 marks, 1 for the formula, 1 for the correct substitution, and 1 for the answer. So if you just have the answer down, you only get 1 out of 3. If you forgot your calculator at home, you'd get 2 out of 3, right? So you'll find, this is ironic, I know, but the higher you get up in the grades, the less the answer matters, right? We don't care about the answer. We care about how'd you get it? Like, show us how you got that, right? And some questions may take a whole page, right? And, you know, because I've marked a lot of diplomas and stuff, if you had a question out of 10 and you had the wrong answer, you would still probably get 9 out of 10 on that. Even if you substituted, see, maybe you put a 3 where a 2 was, but you've done all this work. And every step is different than the step that I have. Every answer on every step. But because you made that one error, it messed up everything. I would have to see that error and go, oh, but they still did that step right, that step right, that step right, that step. And even though you got a different answer than me, you would still get 9 out of 10 because you cannot be penalized for the same mistake twice. So if you put a 3 in there instead of a 2 and you got the next one wrong, I'm not going to mark it wrong. And the next, because of course they'd all be wrong. You'd get 0 out of 10 if I just looked at that, right? And even when I mark yours, if you do the formula, you substitute it, but you get the wrong answer, you're still going to get more marks than if you just put the right answer and didn't put the other stuff. Now, obviously, you get full marks if you did all the work and you did your answer. And even walking around today, right? You guys would do the work right, but you would put it in your calculator weird. You'd maybe put in a 3 or 2, and I could catch it because I could go, your work's right, but your answer's wrong. So put it in your calculator again. You'd put it in your calculator, and then you'd get the right answer. So showing your work to see how important it is for me even to be able to help you to see what are you getting, what are you not getting. Okay, so for this one, where A is 10 squared and B is 2 squared, that's going to equal C. So if we go and put that in, we get square root 104, which is 10.2 equals C. Okay, so you're going to go, so I'm going to show you, I'm going to turn this on. So you go second, and then this button right here. Do you see where my arrow is? And hit that. Okay, work? Okay, and that's why it's nice when we all have the same kind of calculator. And because you know what? That calculator it's awesome. And it's like indestructible. I've seen students drop those things 100 times and don't break. So that's a good thing about them. But the cool thing about it is when you get to your diploma, it's something you've been using for 3 years. And you're going to know that thing well. As opposed to the person that hasn't been using it for 3 years and they pick it up to go into the diploma, they might not even know where the square root button is. Right? So it's valuable to be able to just, you know how it is, right? A computer, anything. You know, when you first get that, especially get a Mac. Like I had a PC and went to a Mac and everything's different, right? But I learned how to use a Mac now. So, okay, let's do this one right here. Okay, so number 3, which is 4 for you, right? Now, this says find x. Okay, so what do we need to find x? We got to find y first, okay? One of those problems. Don't you love those ones? You're like, oh, crap. I got to find that one, then I got to do this one. Okay, so how will I find y? What is y? A, that's my altitude. Good. So let's do this triangle first. Then after I find A, then I can do the other triangle. So I would do this by going a squared plus b squared equals c squared. I'm looking for A, so I'm going to subtract b squared to both sides. A squared equals c squared minus b squared. Take the square root. A is the square root of c squared minus b squared. Okay? Again, I know you're probably saying, I have that memorized. I just want to show you how to do it. So it takes away the magic, right? So this is 9 squared minus 6 squared. Okay? And that's going to give us 6.708. And I don't want to round too much, right? Because if I round that, and then I go and do my next part, The next part's going to be off a little bit because I round it. So you never round until the end. So now I know what A is. Now I can find, which letter am I looking for now? C. So C, well, we know this one well enough. It's just A squared plus B squared, right? So C equals the square root. A is 6.708 squared plus B is 3 squared. C equals 7.3 decimeters. Okay. Why is it decimeters? Because that's the units we've been doing. Is this making sense? Yeah? You guys remember doing this last year, right? Okay, we're just going to do one more because it's a bit trickier. Oops. Okay, don't look. Hide your eyes. Okay. So it says this is a square and there's a diagonal drawn right through it. So you don't have that diagonal, do you? So just draw a diagonal from corner to corner. Oh, you don't even have a square. Okay. Okay, so just draw a square and go corner to corner. It says that the diagonal of this is 13 centimeters. And it says find the length of the side right here. Okay, let's do this one as a class. Anyone got any ideas? Yes. Right? Dividing it by 2 doesn't work, actually. That's what a lot of students go for. They want to divide it by 2. When in doubt, no, it doesn't work either. Yeah? You want to help them out? The dividing by 2 is what gets you in trouble. No. Okay, so I want to let's just right now, I want you to just draw this as another triangle. Okay, let's just look at this triangle. Now, do we know anything more about this triangle right now before we go on? What's the altitude? What is the same as? We do know the altitude, don't we? What's the base? X. Therefore, the altitude? X. Why is it X? Because it's a square. So that is X as well. Okay? Oh, yeah. So, right. If you square it and then divide by 2, that's right. Okay, that's right. I get it now. I was actually not listening well. So but this is how you would do it without the magic. It's a squared plus b squared equals c squared, correct? I'm just going to, a is x, b is also x, equals, does everybody get that? Okay. Now what's x squared plus x squared? It's actually 2x squared. X squared times x squared is x to the 4th, but then you would get 13 squared. Now, how would you go and solve this? What would you do next? Let's do some algebra. Yes. Yeah, divide both sides by 2. 13 squared by 2. And that's gone. Now we have x squared equals 13 squared over 2. Now how do we solve for x? So this is where I was kind of, because this is the one thing we haven't done yet when people describe it to me. How would I find x? What do you do to x squared to find x? You square root it. So we will square root this as well. So I'm going to write it underneath. X is the same thing as the square root of 13 squared over 2. Okay, so if you get your calculator out, you're just going to go the square root of 13 squared divided by 2. And you get 9.19 or 9.2 centimeters.